All right, in this video here, we're going to talk about simplifying fractions. So to start off, I drew up here, three visual representations of three different fractions. We have 1/2, right? There's a circle there. 1 out of 2 pieces is filled in. We have a circle divided into 4 pieces where 2 of those pieces are filled in, so that's 2/4. And then the circle over here divided into 6 pieces. 3 of those are filled in, so that's 3/6. Now, all 3 of those fractions, though, half of the circle is filled in. Right, so 1/2, 2/4, 3/6, they all just equal 1/2. Right, there's the same portion of the fraction is filled in, whether it's 1 out of 2, 2 out of 4, or 3 out of 6. Right, so those fractions are equivalent to each other. Right, and when we start talking about simplifying fractions, we talk about basically if I have a fraction like 2/4 or 3/6, is there a way to express that relationship between those two numbers, between 2 and 4, between 3 and 6, using smaller numbers? Right? Sometimes people refer to this as reducing a fraction. I don't like to use that term reducing because it makes it sound like you're actually reducing the value of the fraction. You're not reducing the value of the fraction, right? 2/4 is equal to 1/2, right? All right, so we're simplifying it from 2/4 into 1/2. We're reducing the value of the numbers that we're using, right? 2 gets reduced to a 1, 4 gets reduced to a 2. That's why some people call it reducing a fraction. Like I said, I prefer to use the term simplifying. Because 2/4 is not reduced to 1/2, it's equal to it, it's just kind of simplified, right? Same with 3/6 and 1/2, right? So, if I'm not looking at the pictures, it's pretty clear when you look at the pictures, even though somehow I drew my circles 3 completely different sizes, but still it's completely clear when you're looking at those pictures that each one of those represents 1/2 of the circle, right? So 2/4 and 3/6 are both also 1/2, right? But if I'm just looking at the fraction 2/4, how do I know that that equals 1/2? Right, well, to do this mathematically, again, without having to draw pictures, we think about it in terms of factoring. Right? Factoring means breaking a number up into the things that multiply together to give you that number, which, when I just said that definition, it sounded a little bit confusing, but I'll show you what I mean. Right, so 2, right, well, what numbers multiply together to equal 2? Well, 2 times 1. That's basically the only numbers that multiply to equal 2. What numbers multiply to equal 4? Well, 2 times 2 equals 4. All right, so 2/4, I can write that as 2 times 1 over 2 times 2. All right, and one of the properties of fractions is that if I have multiplication in my numerator and denominator, and any of those factors match up, those factors are going to cancel out. Those matching factors will cancel out. So the 2's that I have here, the 2 on the top and the 2 on the bottom, will cancel each other out, and I'm left with a 1 over 2, which is 1/2. Right, now technically what happens here, if I just kind of show you an extra step just to kind of show you why this works. Right, so I have 2 over 2 times 1/2. I can separate that into the fraction 2 over 2 times 1 over 2. Right, 2 times 1 over 2 times 2. Right, I can separate those because when I multiply fractions, I just multiply the numerators together, I multiply the denominators together. So I can use that fact to also separate those fractions. Right, so this is 2 over 2 times 1/2. But what does 2 over 2 equal? Well, anything over itself equals 1, so that's 1 times 1/2, and anything multiplied by 1 equals itself. So 1 times 1/2 equals 1/2. Right, so that's technically what we're doing here is we're splitting up 2/4 into 2 times 1 over 2 times 2, and then I'm splitting up that matching factor, that 2 over 2. I'm kind of pulling that out into a separate fraction, which equals 1, and then 1 times this 1/2 here just gives me the 1/2. Now, the shortcut to doing that is what we did originally. When I have 2 times 1 over 2 times 2, if any of those factors match, the 2 on the top and the 2 on the bottom, I cancel those out, and what I'm left with is that 1 over 2. That gives me my answer of 1/2. Right, now, this canceling of the factors thing in the numerator and denominator, that only works if the numbers on the top and bottom are being multiplied. Right, what I can't do, if I had 2 plus 1 over 2 plus 2, right, I cannot cancel out the 2's there and get 1/2. Right, that does not work. That's not right. Right, because remember, 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 1 over 2 plus 2 actually equals 3/4, which is not the same as 1/2. Right, so doing this canceling thing of the factors in the numerator and denominator, that only works if the numerator and denominator involves multiplication. If it involves addition or subtraction, you cannot cancel out numerators and denominators. Right? It's a real common mistake I see people make, so I just want to point that out. That's not allowed. Right? Only when there's multiplication there. All right, so that is that. And one other thing to point out on this one, the 2 in my numerator, I actually have 2 factors of 2 in the denominator. But when I do the canceling out, it has to be like a 1-to-1 canceling. So this 2 up here cancels out one of the 2's in the denominator. It doesn't cancel out both of those 2's. Right? If I had 2 2's in the numerator and 2 2's in the denominator, then all of those 2's would cancel. Right? 1 2 cancels out 1, the other 1 cancels out the other one. Right? It has to be like a 1-to-1 canceling. All right? All right, so that's 2/4 equal to 1/2. Same thing for this one for 3/6. I want to just quickly go through that. Right, 3/6, if I factor the 3 and the 6, well, 3 is equal to 3 times 1, 6 is equal to 3 times 2. Right, and notice they have a common factor. My numerator and denominator each contain a factor of 3, so I can cancel out those 3's, and I'm left with 1/2. Right, so that's how we can show mathematically that 2/4 and 3/6 also equal 1/2 without resorting to drawing, pictures up here. All right, so that is, real quick simplifying fractions. What I'm going to do here is pause the video and erase this and put up a couple problems with some bigger numbers that don't involve pictures, and we'll go through this process of factoring and canceling to simplify those fractions. All right, so I put up a few more problems here. Well, I put up a few more fractions here that we're going to try to simplify. Now, I would encourage you, if you feel somewhat confident with what we did at the first part with the 2/4 and the 3/6, if you want to just pause the video and try to simplify these yourself, and then maybe run the video again and just kind of listen to what I say and see if you did it correctly, that would be a great thing to do. Or maybe just watch me do the first or second one and then pause it and try to do the third one. However you want to do it, but the best way to learn how to do these things is to actually try them yourself. So for any of these videos, anytime you feel like you can maybe try it, pause the video, try it, and then, like I said, roll the video and see what happens. All right, so the first fraction we have here, 10/45. All right, so I want to try to simplify that fraction if I can. Now, not every fraction can be simplified, but anytime you're doing a math problem and you get a fraction as your answer, you need to check to see if that fraction can be simplified. You always want to give your answers in the simplified form if you can. All right, so 10/45. Well, let's see if we can factor these. 10, that's equal to 5 times 2, and 45 is equal to 5 times 9. All right, so I have a factor of 5 in both my numerator and denominator. Those are going to cancel out, which is going to give me 2/9. All right, so I get 2 9s, so 10/45 is equal to 2 9s. If I were to draw a circle and divide it into 45 pieces and then color in 10 of those, and then I did another circle and divided it into 9 pieces and color in 2 of those, I would have the exact same portion of the circles filled in. Right, now, this is why we want to have this mathematical method. Like I did earlier with the 2/4 and the 3/6, that wasn't that hard to draw a circle and cut it into 6 pieces and color in 3. I do not want to draw a circle and cut it into 45 pieces and color in 10. That's going to take a long time. That's why we have these mathematical methods to do these things. All right, so we get 2 9s. Now the question is, well, can I simplify 2 9s any further? Right, sometimes fractions can be simplified more than once depending on how you factor it in the beginning. Well, let's see. So 2 is equal to 2 times 1. Right, there's really nothing else I can do to factor the 2. 9 is equal to 3 times 3. Right, and do I have any common factors here in the numerator and denominator? I don't. Right, I have a 2 and a 1 in the numerator. I have a 3 and a 3 in the denominator. Nothing there is going to cancel out, and so my answer is just 2 9s, right? That cannot be simplified any further because when I factor it, I don't have any common factors. All right, so 10/45 is equal to 2 9s. That's the most simplified form of that fraction. All right, the next one, 12/18. All right, well, let's factor 12. 12 is equal to, what, 4 times 3? And now can I factor the 18 to have either one of those numbers? Well, 4 won't divide evenly into 18, but 3 will, right? 18 is equal to 6 times 3. And now my 3's, right, my 3 in my numerator, my 3 in my denominator can cancel out, and I'm left with 4/6. All right, so 12/18 is equal to 4/6. I simplified it. Did I simplify it completely, or can I go further? Well, 2, I almost said the answer there. 4 is equal to 2 times 2. 6 is equal to 2 times 3. And I have a factor of 2 in both the numerator and denominator, so this one does simplify a second time. And when I cancel out those 2's, I get 2/3. And I know I can't simplify 2/3 anymore because 2 is just 2 times 1 and 3 is just 3 times 1. And even if I do that and I cancel out the 1's, I still have 2/3, right? Nothing is really going to change there, right? So 2/3 is my most simplified version of 12/18. Right, so this one involved 2 steps. First I canceled out the 3, then I canceled out the 2's, and I got my answer. Right? Could we have done this in one single step? We could have if we had factored it this way. Right? If I had said 12 over 18 equals 6 times 2 over 6 times 3, if I notice that both of these share a common factor of 6, and then I cancel out the 6's, that gives me directly 2/3. Right? So simplifying, sometimes it takes multiple steps, but if you recognize the bigger number, that's a common factor of 12 and 18, in this case the 6, you can kind of get to the answer a little bit quicker. Right? So when you're trying to factor these and you're trying to simplify those fractions, think about, well, what's the biggest number that I can divide into both 12 and 18? What's the biggest factor that they share? And then you can get a little bit quicker to your answers when you're doing these types of problems. All right, last one, 20 over 68. All right, so 20 over 68, well, they're both even numbers, so I know I can at least divide them both by 2. So let me start with that. 20 is 2 times 10, 68 is going to be 2 times 34, and my 2's are going to cancel out, so I get 10 over 34. Well, I can simplify this further because 10 and 34 are still both even numbers, so I can factor them and divide them both by 2. So 10 is 2 times 5, 37 is 2 times 17. Once again, the 2's cancel, and I'm going to get 5 over 17. And 5 is just 5 times 1. There's no other factors of 5. 17 is just 17 times 1. There's no other factors of 17, right? 5 and 17 are both prime numbers, just like the 2 and the 3 were up here, just like the 2 and 9 were up here. So anytime you simplify your fraction and your numerator and denominator are both prime numbers that can't be factored any further, then it's simplified as much as possible. There's nothing else we can possibly do to simplify 5 over 17. Right, so once again, this one took us 2 steps. We could have done it in 1 step if we had recognized that both the 20 and the 68 have a factor of 4. Right, 20 is 4 times 5, 68 is 4 times 17, and the 4's cancel out, and that would have given us the 5 17ths in 1 single step. Right, so depending on how well you know your multiplication tables, how well you're able to factor numbers, if you're good at that stuff, simplifying fractions is a little bit easier. If you're not so good at recognizing what numbers divide into 4 or 20 and 68, then you might have to do multiple steps to simplify your fractions. Right? But that's how we always simplify fractions. We look at our numerator and denominator, factor each one, see if they have any common factors that we can cancel out, and then try it again with our answer until we're sure that there's nothing else they have in common, and then we've simplified it completely. Right? And we will be using this method again later on in algebra when we're simplifying rational expressions that involve algebraic expressions, x squared minus 1 over x squared plus 2x plus 1, and we have to simplify that. We're going to do it the same way by factoring. It's just the factoring is going to be more difficult because we're dealing with algebraic stuff instead of just numbers, but the mathematical principle behind it is exactly the same as what we did here. So an important thing to remember, and like I said, anytime you're solving a problem and your answer comes out to a fraction, try to simplify it, do this. If the answer comes out to 5 over 17, that's it, you're done. If it comes out to 20 over 68, you need to simplify it and give your answer as 5 over 17. All right, so that is simplifying fractions.